Question number 1. The discrete random variable x has the following probability distribution. Okay, so we can see that from the table that probability of getting a 1 is 0.3, probability of getting a 3 is A, probability of getting a 5 is B, and probability of getting a 7 is 0.25. There should be an X written over here. Okay, write down the equation satisfied by A. So to form A and B. So to form an equation, we know that the sum of all probabilities is 1. So 0.3 plus A plus B plus 0.25 equals 1. And we can move the constants to the other side. That would give us 0.45. This is the answer for part 1. Part 2, given that expected value of x is 4, this is actually the mean. Find the value of A and B. Now the formula for expected value is given in the formula sheet, which is x times probability. So we're going to keep multiplying the x with the probability plus next x with the probability plus next x with the probability plus next x with its probability, and the answer is equals to 4. Now when you will move the constants to the other side, you'll get 1.95. This will be our equation 2. And now you can solve equation 1 and equation 2 on your own using simultaneous equations. And you should get A equals 0.45 and B equals A is 0.15 and B would be 0.3. And that's the final answer for question 1. Number 2, a box contains 10 pens, of which 3 are new. A random sample of 2 pens is taken. Show that the probability of getting exactly 1 new pen in the sample is 7 by 50. Okay, so if we're getting 1 new pen, that means 1 pen is new and the other pen is old. So we're finding the probability of new and old. Or it could also be that the first pen comes out to be old and the second pen comes out to be new. So that's why we will find the probability once and then double it. So probability of getting a new pen would be 3 by 10 times. Now probability of getting an old pen would be, there are 7 old pens and now in total we have 9 pens, times 2. And this would come out to be 7 by 15, and that is what we had to show. Okay. Part 2. Construct a probability distribution table for the number of new pens in the sample. For that, you make an x here, a probability x is equals to x here. Okay. Now, this table is for the number of new pens selected. So we may have no new pens, or 1 new pens, or 2 new pens selected. Since 2 pens are being selected, we can't have more than 2 new pens. Okay, we've already found the probability of getting exactly 1 new pen. That's 7 by 15. Now let's find the probability of getting 0 new pens. That is old and old again. Okay, so probability of getting an old pen would be 7 by 10. And probability of getting an old pen again would be 6 by 9. This time we won't double it because old and old is the same as old and old. So you don't double it. So this gives us, this will also be 7 by 15. So we get 7 by 15 here. Now to find this, that both the pens are new and new, you have 2 options. Better option would be just add these 2 and then subtract the answer from 1. Or you could find the probability of 1 new pen, which would be 3 by 10 and the second new pen, which would be 2 by 9. This comes out to be 1 by 15. And if you had added these two and then subtracted it from 1, we would have gotten 1 by 15 again. This is 1 by 15. Okay. All right. So moving on. Part 2 is done. Part 3, calculate the expected number of new pens in the sample. That is, we have to find EX, and we know the formula for that. Like I said before, it's given in the formula sheet, which is summation X times probability. So 0 times 7 by 15 plus 1 times 7 by 15 plus 2 times 1 by 15, which comes out to be 3 by 5. The number 3, a discrete random variable X has the following probability distribution. We can see that in the table. Part 1, find the value of the constant C. Okay, so we know that the sum is going to be 1, sum of all probabilities. So we add them together and equate it to 1. All of these added together give us 18C. So C comes out to be 1 by 18. Okay. So before I start part 2, I'm going to replace all these three C's with 1 by 18. So 3 times 1 by 18 will be 1 by 6. 4 times 1 by 18 would be 2 by 9. Then 5 by 18. And then 6 by 18 will be 1 by 3. Okay. I'm just confirming that this sum should be 1. That would mean that I have not made a mistake. Yes, it is. Okay. So now in part 2, we first have to find the expected value. The formula for that is summation xp. So 1 times 1 by 6 plus 2 times 2 by 9 plus 3 times 5 by 18 plus 4 times 1 by 3. And that gives us 25 by 9, and preferably write this as a mixed number, 2 whole 7 by 9. Next, we have to find variance. Variance is also, the formula is given, which is summation x square p minus square of the expected value. Okay, so let's do that. We'll have 1 square times 1 by 6 plus 2 square times 2 by 9 plus 3 squared times 5 by 18 plus 4 squared times 1 by 3 minus mean that was calculated just before this, mean squared. Okay, this will give us 95 over 81. And preferably, we write this as a mixed number as well, 1 whole 14 over 81. Part 3, find the probability that x is greater than ex. So the x, these are the x. X is greater than ex. Ex is 2 whole 7 by 9. So that means probability x is equals to either 3 or x is equals to 4. So that means we have to find or add these two probabilities, probability of 3 and probability of 4. So probability of 3 is 5 by 18 and probability of 4 is 1 by 3. That gives us 11 over 18. This is the answer for part 3. Two fair dice are thrown. Let the random variable x be the smaller of the two scores if the scores are different, or the score on one of the dice if the scores are the same. Copy and complete the table to show the probability distribution X. Okay, so in such cases, the questions become very easy if you draw possibility diagrams. So in the first row, we get 1, 2, 3, 4, or 5, or 6. And in the second row, we get 1, 2, 3, 4, 5, or 6. And the question says that we choose the smaller of the two scores if they're different and one of the scores if they're the same. So when we get 1 and 1 on both the dice, the score is going to be just 1. For 1 and 2, the score will be the smaller number 1. For 3 and 1, it's going to be 3. Sorry, for 3 and 1, it's going to be 1. For 4 and 1, 1. 5 and 1, 1. And for 6 and 1, it's going to be 1 as well. Similarly, for 1 and 2, we'll get 1. For 1 and 3, we'll choose the smaller one, which is 1. And similarly, we'll have 1, 1, and 1 here as well. Okay. For 2 and 2, it's going to be 2. For 3 and 2, it's going to be 2. For 4 and 2, 2 for all of these. And 2 for all of these as well. Then we'll write 3 here, 3, 3, 3, 3, 3, 3. What are we doing? We're choosing the smaller value out of the two throws. So for 4 and 4, we're going to just choose 4. For 5 and 4, we're going to choose 4. For 6 and 4, we're going to choose 4. Then for 4 and 5, we're going to choose 4. For 4 and 6, we're going to again choose 4. And similarly 5, 5, and 5, and a 6. Okay, now we can see all of the 36 outcomes and we can easily find the probabilities of getting a 1 or a 2 and a 3 and so on. So a probability of getting a 1 would be, how many ones do we see? 6, 7, 8, 9, 10, 11, 11. So 11 over 36. How many 2's do we see? 9, 9 over 36. There are a total of 7 3's, so 7 over 36. Then 5 over 36. Then 3 over 36. And then 1 over 36. Now, if you add all of these together, you'll also get 36 over 36, which is 1. Okay, always check that to make sure that your probability distribution table is correct. Okay, in part 2, we have to find the expected value, which is summation xp. So 1 times 11 by 36 plus 2 times 9 by 36 plus 3 times 7 by 36 plus 4 times 5 by 36 plus 5 times 3 by 36 and plus 6 times 1 by 36. Enter all of this in your calculator and you will get 2.52777 rounds to 2.53. Question number 5. In a competition, people pay $1 to throw a ball at a target. If they hit a target on the first throw, they receive $5. If they hit it on the second or the third throw, they receive $3. And if they hit it on the fourth or the fifth throw, they receive $1. People stop throwing after the first hit or after 5 throws if no hit is made. Mario has a constant probability of 1 by 5 of hitting the target on any throw independently of the result of the other throws. Mario misses his first and the second throw and hits the target on the third throw. State how much profit he has made. Okay, so he paid $1 to play this game, and then he hits the target on the third throw. On the third throw, he receives $3, which means the profit he's making is $2. So it's just 3 minus 1 equals $2. Okay. Show that the probability that Mario profit is $0 is 0.184. Correct to three significant figures. Okay. So when is the profit $0? That is why when he gets $1 back and he had also paid $1. So 1 minus 1 is 0. So probability of profit being zero, probability of profit being $0, that happens when he either hits the target on the fifth throw or the fourth throw, because both of the times he gets $1 as a reward. Hence, the profit is zero. So that means that he hits it on the fourth throw means miss, 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 and hit, or miss, 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 and the fifth one is the hit. Okay, so the probability of hitting is 1/5, which means probability of missing is 4/5. So we're going to write 4/5 for all of these misses. And since there are 3 misses, I'm going to cube it times 1/5 plus we have 4 misses here. So 4/5 power 4 and a hit, which is 1/5. Okay. This comes out to be what they had asked for, 0.18432. You must show a longer answer before showing this 3 significant answer. Rounds to 0.184 in 3 significant figures. Okay. Next is draw up a probability distribution table for Mario's profit. Okay, so we'll write X for the upper row and probability X is equals to X. Okay, what is the highest profit he can make if he hits the target on the first throw? He gets $5. So that's a profit of $4. So I'm going to start with $4. Next, he gets $3. So that would be a profit of $2. Next, he gets $1. So that's a profit of $0. And lastly, if he does not manage to make a hit, he does not get that $1 back. So that's a profit of -$1. You don't have to write the dollar symbol, by the way. You can just write 4, 2, 0, and -1. Okay, now we'll have to write all these probabilities. What do we already know? We already know the probability of making a profit of 0 is 0.18432. And we're going to calculate the rest. Probability of not making any profit at all would be miss, 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 and miss. So probability of -1 would be miss them all. That will be 4/5 power 5, which gives 0.32768. So I'm going to write that here, 0.32768. Okay. Next, we could either find for $4 or $2. I'm going to find for $4. So probability that the profit is 4 would be first should be a hit. So it's just going to be a hit in the first attempt. So that's a probability of 1 by 5. So probability of uh, making a profit of $4 is 1 by 5, or since everything else is in decimals, we're going to write 0.2. Okay. For $2, uh, we could just add the rest and subtract it from 1. So instead of doing the working for $2, I'm going to do 1 minus 0.2 plus, use long decimal value, don't use the rounded values here. Okay, this would give 0.288. Okay, all right. Probability distribution table is done. Calculate his expected profit. We know the value. We know the formula for expected value. It is EX equals summation XP. So multiply 4 with 0.2, then 2 with 0.288, then 0 with 0.18432, and then negative 1 with 0.32768, which gives us 1.05. The discrete random variable x has the following probability distribution as seen here. Find the value of q, which means we sum all these probabilities and equate it to 1 to get the value of q. So 0.26 plus q plus 3q plus 0.05 plus 0.09 equals 1. We get 4q here, and move everything to the other side, we get 1 minus 0.09 minus 0.05 minus 0.26, which gives us 0.6 divided with 4, and we get 0.15 as Q. Part 2, find the expected value, which has this formula given in the formula sheet, x times p. Summation. So we do 0 times 0.26 plus 1 times q is 0.15 plus 2 times what is that times 3, 0.45 plus 3 times 0.05 and plus 4 times 0.09. All of this collectively gives us an expected value of 1.56. Next, we have to find the variance. The formula for variance is summation x squared p minus expected value squared. Okay, so we will do 0 squared times 0.26 plus 1 squared times 0.15 plus 2 squared times 0.45 plus 3 squared into 0.05 plus 4 squared into 0.09 minus mean squared, and the mean or the expected value was this 1.56 squared. Okay, if this was standard deviation, we would have square rooted all of this. Okay, now we enter all of this in our calculator and we'll get 1.4064, which becomes 1.41 after rounding.